Welcome to another video on my Raspberry Pi running Raspbian Linux and attempts to use hardware pulse width modulation and software pulse width modulation at the same time. Software pulse width modulation works as proven on this LED and with some wiring also on this LED. Hardware pulse width modulation on this motor via this circuit doesn't work as yet. Last time I tried to get the frequency range correct. I was told that the frequency range is between 100 and 200 Hertz for this motor, and with this part of the code it should be working. Question is, does it? And for that I haven't had any success yet. Now this is the other view using a webcam, and oh, by the way, this is with streaming video with or without any delay, usually with some delay, using the Raspberry Pi Cam version 1, by the way. And let's try to get it to work. Well, something to work. And this is the program. So you will see, and let me get this one as well. Now you should be able to see an LED blinking. And that is a bit vague, since I am not seeing any blinking of this LED either. So that is not good. The motor doesn't work unless I do this. But this is, and it stops, and you see the this LED blinking quite fast, and I'm not sure what that causes. Another point is that I'm not seeing this LED run. Now you see the delay in this image, between this image and this image. So why is this LED not working? I didn't change anything in the wiring. That's a mystery to me, and things should be working, of course, but even now it doesn't run. The big question is why. It usually indicates that if this one is not working, there's no power, which also indicates that this one won't work. Well, the program is running as it did, but I have to investigate. Why is this LED not burning? Well, it did, but it stopped. And why is this one not responding to software pulse modulation, which is caused by this part? And it should blink quite fast, not too fast for the blinking for the naked eye, but that is a big question. Why? So let me first find that out. Without me doing anything, it has started to work. Well, partly. As you can see, this LED burns, this one does, but as yet I have to witness this LED to function, and I wonder why. The only thing, it does, it actually does. So what is the reason? I have no idea. The only thing is, though, that looking at let me shift this one down for a bit. If I look here, it should go on and off pretty quickly, but here I have a 5 seconds sleep, and here and here and here too. 2 seconds, that is. So in total it only flashes very short, and then I have quite some waiting. What happens if I say, alright, let's stop this one and diminish this time to 2 seconds, this time to 2 seconds, this one, clear channel. Well, clear channel should be done instantly, so no time to waste there. This should go faster, but will it help? So let me shift this back. Well, it certainly goes faster through the routine, but that's only because I shortened the timing. So, alright, let's focus now on the frequency, because that is still a mystery to me. I need 200 Hertz. And as I've shown in Maxima, 200 Hertz, 200 vibrations or periods a second means 1 divided by 200, 1 divided by 100, well, 1 divided by 100 is decimal 0.1, so 200 is decimal 0.2, of course. But how to make that in this? And I also have to review this one, and that makes it all uncertain, because when I make this larger, this has to be 0. The larger this number, the lower this number has to be. And that with the frequency that I'm still puzzled. It's 20,000 microseconds. 20 seconds. No, that's not entirely true. Not 20 seconds. 20 milliseconds. So, how to interpret this? That is still a very good question. Let's reason about it some more. But on the other hand, I'm happy that without me doing something, the electronics work and the motor runs, be it on power and not on pulse width modulation. Alright, studying the whole thing once again, and that means that I am studying this page once again. Pulse width modulation via DMA for Raspberry Pi. Now here it seems quite logical. I start at 0 with 50 width, starting at 100 at 50 width, then to the lower side of the page. This might not much sense to me, but here, this example with an oscilloscope, he uses servo for the most part. Here he still uses servo, but now he starts using low-level methods to add a further pulse to subcycle. So he adds a subcycle, a pulse actually, to this subcycle. And then it turns out that well, you start at something, 200 times 10 microseconds is 2000 microseconds. And the start is at 200. Now if you go to my code, you see here the start at 1975. Going here, 1975 is 1975 times 10 is a lot. A width, and once again back to my code, is 20. So here would say width is 20, makes then 200 microseconds. So I shouldn't start at 1979. I should start somewhere a lot earlier. Another thing is that when I look at this propeller, the way it responds via the software is with voltage quite often. But if I see how long it takes to get the pulse and to get it running, it doesn't start at 0 volts. It doesn't start with a very low pulse width. You have to give it some pulse width and then it starts, and then you get eventually lower, and it responds with a delay. So it takes time for it to stop, and it takes unless you completely remove the power, of course, but otherwise it takes time, and that is the problem here. So this doesn't matter. I mean, this time is very short. Now how do we do it here? 0 and 5. Compare this to this, then the width of 5 is extremely short. So I think I should increase that to 500 at least. But then again, I need to keep in mind 100 Hz and the 500 and the 200 Hz. So once again, 1 divided by 100, and then to float, obvious, 1 divided by 200, obvious, and I think this one I used for my code, decimal 005. So what to do? What is wisdom? It's a very good question. If I think to start here at 200 Hz or at 100 Hz, it's 5 times 10 microseconds. This is, so to say, 15 times this is supposed to be 150 Hz. I doubt very much that is the case. But also, this is not what I think it is. So let me put this to 500. Let me put this to 1000. But then also taking on this, is this really, well, is it really according to this? I doubt it. Then again, how much time do I need? I think 2 seconds is too few. So I'll put this back to 5 seconds. Let me just try. Alright. Let's give it a try. Who knows? So with this change, will it work or not? I have my doubts, but let's see. To be honest, I don't see any difference at all. That can mean two things, of course. It can mean I'm still misinterpreting everything. It can mean that looking at this, I'm filling in things the wrong way. Another thing is, of course, looking here, this is, well, let's take this one, doesn't matter. A period is one up and then not flat. Usually a period is like this movement, a sinusoid, and then the upper part you would see here, lower part you would see somewhere there, unless this is the middle line. Then, but if I look at this and I take a look here, this is only a pulse and not a real period. So what are they doing here? It is a pulse that they do. So this is the 0 line. Then you have a pulse, and then you have to wait. Pulse width is then the total pulse width is if the total pulse width is 1 or whatever it is, then it goes at fastest. The less the pulse is, say if you have a pulse width that only covers 50%, it goes half speed. So now you have only one pulse width starting at 2000 microseconds, 2 milliseconds, with a width of 1000 microsecond, 1 millisecond, and that is only this second pulse. And it then starts at, well, 0, 1, 2 microseconds. Given the fact that the complete period is how much time? 1, 2, 3, 4, 5, 10, 15, 20 microseconds. No. So this is 1 microsecond. One, 2, 3, 4, 5. This is 5000 microseconds. 10,000, 15,000, 200, yeah. 5,000, 10, 15, 20,000 microseconds. Which, by the way, is very subcycle time is 20,000 microseconds. So the question is, what is wisdom for me to do? I can't go any higher than 19, and that makes sense. 1999 times 10 is 20,000. Yeah, that makes 20,000 starting from 0. That's the complete time. You can't go any higher. And that's the whole trick, of course. So how long do I want it to run? Well, half of it, 5,000. No, half of it is 10. Actually, not even 10, it's 19, it's 999. This is the half time. And then I also need a half time for the other. And I think there is kind of the trick. But this is at the same time. So when I leave this out, oops, doesn't matter. Oh, really? So now I have it at start, and I have it here. Does this work at all? A very, very good question. Let me put this to 5. And see what happens then. Not giving up. So, last part of this video. Let's give it another try. No, not this one. I need you. I need you. Is there any change at all? And I'm afraid to say there is none. Alright. Let's do it another way then. Let's make it 10. A sleep of 10 seconds. Does it do anything? No, 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 not here. Does it make a difference anyway, anyhow? And I have to say, with bare naked eye, there's no change whatsoever. So what I should do is having a oscilloscope. The only problem is I don't have one. Buying it takes a few $100, dollar, and I am not quite sure if that is worth an investment. But with this, I think this is not going to work out unless I still misunderstand things. Well, let me take a look at maxima again. A frequency 20,000 microseconds. If you have 20,000 microseconds, 20,000 microseconds, that is 20. That is 20. No, I'm miscalculating now. $20,000 micro is 20 milliseconds. 20 milliseconds is, going back here, this is 50 milliseconds. 100, no, tenth, hundredth, thousandth. This is 50 milliseconds. I think is 120. It's 1 divided by 200. It's 5 milliseconds. 50 milliseconds would be 500th of a second. Going back here, 20 milliseconds. It is making me crazy. Taking this away makes 20 milliseconds. Twenty milliseconds is 200ths of a second. That's an entire subcycle time. 200ths of a second. So this is a quarter of a subcycle. A quarter. Now, going back to my code, the total is 1999 divided by 4 is not 1999. It is 500. No, 499. So this is 200 hertz. This is 200 hertz. But this is the timing, and then going back here, the width, the start at a quarter and the width is the speed. So would that be 499 as well? Would that work anyway? I have to wait 10 seconds now. It does work. It doesn't give any problem. But also there is no change. There is no change at all in speed. So let me do one other thing. Let me put it to quiet, and that's the last thing I do now. There's no change at all. Alright. Time is up. I'm going to postpone this to next time. Thank you for watching. If you like this video, please subscribe to my channel. Also follow me on Twitter and Instagram. Please donate to keep my blog and website, etc. and videos going. Visit my website for more information. Also see my website for more projects. And this is certainly going to be continued. Bye bye.